In the early stages of string theory research, the theory promised to be the bridge that united the mathematics of Einstein's general relativity with the mathematics of quantum mechanics. String theory would provide a unified theory for the four fundamental forces in physics, which are gravity, electromagnetism, strong nuclear forces, and weak nuclear forces. This led to it becoming known as the theory of everything. If true, string theory would provide a beautifully simple explanation for the behavior of all particles. String theory posits that all particles are comprised of massless strings that vibrate at different frequencies, resulting in the various properties of the particle. These strings can be open or closed and can vibrate, stretch, join, or split. There are many reasons why this view of particles as strings is so elegant compared to the standard model in which particles are viewed as points. To understand string theory, we need to understand how it connects to the standard model and why it is more successful in explaining the four fundamental forces. The standard model explains the building blocks of matter and how they interact according to the fundamental forces. The standard model includes leptons, quarks, forces, and the Higgs boson, which are unique particles whose interactions provide complete explanations for electromagnetism and strong and weak nuclear forces, but provide no explanation of gravity. It was found that one type of vibrating string has properties matching that of gravity, providing an explanation of gravity that fits in with the field of quantum mechanics. So from string theory naturally comes quantum gravity. This proves very promising for the theory. In addition to gravity, string theory provides an elegant explanation of the strong force, the force that binds two quarks to each other, keeping the nucleus of an atom together. In fact, string theory was first thought of because the gluons that hold quarks together act like strings with some sort of tension between them. String theory is also the first theory to predict the dimensionality of space. String theory only works in a universe where there are 10 spatial dimensions, not in the three-dimensional world we perceive ourselves to be in. One explanation for the 7 additional dimensions humans cannot perceive is that there exist 2 categories of dimension. One set of dimensions consists of the large-scale dimensions that we live in, and the other is a set of minuscule dimensions in which strings interact. The minuscule dimensions are too small to be picked up by any machine. This provides an explanation for the lack of experimental evidence to back up string theory. A lot of the argument for the validity of string theory is that the mathematical equations used to explain it are so simple and elegant. String theory equations are just much less complicated than the equations necessary to explain the standard model. One of the main reasons string theory is so elegant from a mathematical standpoint is that it only relies on one dimensionless parameter, the length of the string, whereas the standard model relies on a staggering 19 free parameters. String theory is the closest physicists have come to explaining all the forces that govern the universe with a single all-encompassing theory, making it one of the most promising fields in the study of physics today.